In 1911, geologist Griffith Taylor found a red stain pouring from the face of Taylor Glacier into Antarctica's Lake Bonny. That is the confirmed starting point. Not blood, not a wound in the ice. A real crimson outflow in one of the coldest, driest deserts on Earth. The first evidence payoff is, Blood Falls looks supernatural, but the real explanation is stranger than the name. The red color comes from iron-rich saltwater that has been trapped under the glacier, cut off from sunlight and oxygen, then forced through cracks until it reaches the surface and rusts in the open air. The ice is not bleeding. It is exposing an ancient hidden world. Blood Falls sits in Taylor Valley, part of Antarctica's McMurdo Dry Valleys. The name sounds wrong, because Antarctica is covered in ice. But the dry valleys are a polar desert, scoured by cold katabatic winds and sheltered by mountains that block much of the ice flow. Confirmed, the falls flow from Taylor Glacier onto the ice-covered surface of West Lake Bonny. Confirmed, the region is one of Earth's most extreme dry environments. Interpretive, that setting is why Blood Falls feels so impossible. A red liquid appears in a white desert. A glacier seems to leak. A place that looks dead hides liquid water, chemistry, and microbial survival beneath hundreds of meters of ice. The map is not background, it is the first clue. The earliest explanation was simple, red algae. That made sense at first glance. Red growths can stain snow and ice in other polar environments. But Blood Falls was not caused by algae painting the glacier. Confirmed, later research showed the color comes from iron oxides, not red algae. This is a useful failure. The first answer was not foolish. It was an attempt to explain the visible stain with a known biological cause. But the evidence forced the story underground. The red material was not growing on the surface. It was arriving from inside the glacier. And once scientists followed the chemistry backward, Blood Falls stopped being just a weird stain, and became a doorway into a sealed subglacial system. The red color is chemistry. Under the glacier, the brine contains dissolved ferrous iron in an oxygen-poor environment. When that iron-rich brine reaches the surface, it meets oxygen. The iron oxidizes. In ordinary language, it rusts. Confirmed, iron oxides are responsible for the red staining at Blood Falls. Interpretive, the horror movie visual is really a chemical reaction happening in slow motion on ice. That is why Blood Falls is so visually powerful. It turns an invisible underground reservoir into a surface signal. The glacier writes its hidden chemistry in red. And the message is not death. It is preservation, old seawater, old minerals, and old microbial pathways surviving in a place that should have frozen the story shut. The liquid feeding Blood Falls is not normal meltwater. It is hypersaline brine, water so salty that it can remain liquid below the usual freezing point. Studies point to an ancient marine source, trapped when conditions around the valley were different and concentrated by freezing over time. Confirmed, Blood Falls is fed by iron-rich, oxygen-poor, hypersaline water beneath Taylor Glacier. Confirmed, radar and field studies have traced a briny hydrologic system inside the glacier. Interpretive, the reservoir is like a time capsule, not because it is untouched forever, but because its chemistry has been isolated and transformed under ice. This is the part many viral versions skip. The falls are not just red. They are a sample line from a buried Antarctic water system. Blood Falls also matters because of life. Chemical and microbial studies found microorganisms in the brine system, surviving without sunlight and with little or no oxygen. Instead of photosynthesis, the system is tied to iron and sulfur chemistry. Confirmed, microbial life has been identified in connection with the Blood Falls brine. Interpretive, this makes the site important for astrobiology because it resembles questions scientists ask about Mars, Europa, and other icy worlds. If microbes can survive in cold, dark, salty, oxygen-poor water under Antarctic ice, then the search for life elsewhere becomes less abstract. Blood Falls is not evidence of alien life. But it is evidence that Earth can hide living chemistry in places that look impossibly hostile. For years, one of the deeper questions was not only why the falls are red. It was how the brine reaches the surface at all. Recent work using field sensors, imagery, and glacier observations points toward a dynamic pressure system. As Taylor Glacier moves, pressure can build in briny channels and reservoirs. When conditions line up, the brine is forced through cracks and emerges in pulses. Confirmed, studies have mapped brine pathways within Taylor Glacier and linked flow to glacier dynamics. Interpretive, Blood Falls is not a steady decorative waterfall. It is a pressure release from a cold glacier plumbing system. The glacier is not inert. It is moving, squeezing, sealing, opening, and occasionally letting the buried brine speak. The obvious question is why the water does not simply freeze. The answer begins with salt. Salt lowers the freezing point of water, and very salty brine can remain liquid at temperatures where ordinary water would become ice. Freezing can also concentrate the salt, because pure ice crystals exclude many dissolved ions. Confirmed, Blood Falls brine is highly saline. Interpretive, salt, pressure, and glacier heat processes help maintain pockets or channels of liquid water in an environment that looks permanently frozen. This changes how the glacier feels. From the outside, Taylor Glacier looks like solid silence. Inside, there may be chemical gradients, moving brine, microbial metabolism, and pressure waiting for a fracture. The stillness is only the surface. Blood Falls is often called Mars-like for a reason. The red color comes from iron chemistry, and the dry valleys are cold, dry, salty, and harsh. Those conditions make the site valuable as an analog for extreme environments beyond Earth. Confirmed, scientists study Antarctic subglacial and dry valley systems to understand life's limits. Disputed, whether similar environments elsewhere contain life. Interpretive, Blood Falls helps sharpen the question. Life does not need a forest. It does not always need sunlight. It may need liquid water, usable chemistry, and time. That is why a red stain on an Antarctic glacier can become a clue in the search for life on other worlds. The mystery widens from one glacier to the architecture of habitability. Blood Falls is much better understood than it was in 1911, but that does not mean every question is closed. How large is the full brine network? How old are all parts of the system? How stable is the microbial ecosystem? How will changing Antarctic conditions affect the glacier's internal plumbing? Confirmed, the red color and brine source are understood in broad terms. Interpretive, the remaining mystery is not, is it blood? It is, how much hidden liquid, chemistry, and life can a cold glacier preserve? That is the upgrade this episode needs. The Monster Mask version ends with rust. The scientific version begins there. So what is Blood Falls? The safest answer is this. It is an iron-rich, hypersaline brine outflow from Taylor Glacier, staining the ice red as iron oxidizes at the surface. It was discovered in 1911 by Griffith Taylor. It was once attributed to algae. It is now understood as a window into subglacial chemistry, glacier pressure, and microbial survival. That makes Blood Falls solved in one sense and still profound in another. The red is not blood. But the glacier is not empty. Under the ice is a buried system old enough, salty enough, and strange enough to make one of Earth's most lifeless-looking places feel alive. If you could sample one part of Blood Falls, what would you test first? The iron chemistry, the hidden brine channels, the microbes living without sunlight, or the pressure system inside Taylor Glacier? Tell me which clue matters most to you, and stay with Mystery Atlas TV for the next case where the strangest color on the map is only the beginning.